0.0503
Yes.
times 10 to the negative 27.
Negative 27.
Yeah, 0.0.
Yeah, because number
503
Oh,
times 10 to the
0.05.
negative 27 kilograms. I don't know, I kind of kept it, since it's all 10 to the negative 27, I just kept it 10 to the negative 27. So I guess you could also call it 5.03 times 10 to the negative 29. That's the way you call it. Did anyone put it 5.03 times 10 to the negative 29? Okay, that's fine too.
Oh my god, this is so ridiculous. I never always over.
So all I
And
did
anyone gonna break this one? Because I just broke this up.
And how, what did you guys get as the energy?
Negative 4.5.
Well, first of all, who is heavier than the nucleus or the protons and neutrons?
Protons and neutrons.
Good, protons and neutrons were heavier. So if you're going to gain mass, then what did I have to do to that? I mean, who has more energy then, the nucleus or the protons and neutrons?
Protons and neutrons.
Yeah, well, it's a tough thing. It's kind of like if you're going to break up that nucleus into protons and neutrons, then you have to add energy to it.
Yeah.
You know, because like the protons and neutrons, I mean, the helium nucleus has this mass, but after it splits up, it's got more mass. Where did that extra mass come from? You had to put energy in order to split those guys apart. You know, so you'd have to put in this amount of energy, and so it's actually energy taken in.
Yep.
And the energy is going to be delta MC squared, which ended up being 4.53 times 10 to the negative 12 joules. Did anyone get that answer?
Yeah.
Okay. Yeah, you just plug it in, delta MC squared.
So the B is this.
Any question or comment? Then I need to have you do another problem because I want you to be exposed to different units that they use. I gave you a problem using units that you're very familiar with, kilograms, and joules. Now I want you to do a problem that involves units that you're not so familiar with, which is atomic mass units and electron volts.
AMU.
So let me see which problem I'm going to have you.
Abu.
AMU.
Yeah. So look in your sheet, like look at the problems I gave you. Could you find 2001? It's problem number 7 from the year 2001. So it should be the first page you have, but I don't know how you have it. But I see it's problem number 7 from 2001. All I need you to do is parts
Oh.
Don't worry. A and B.
It's fine, it was fine.
Might have changed. They were 24 years. What the fuck? Hashtag, I don't know.
So it's this one.
Is everybody there on number 7, 2001, where it says consider the nuclear fusion reaction that uses deuterium as fuel? Are you guys on that one? Okay, so there's a couple things I want to tell you. First of all, do you notice they're giving you the mass in terms of U, atomic mass unit?
Yeah.
Does everyone know what an atomic mass unit is? What is an atomic mass unit defined as?
Weight of
1/12 the weight of a carbon atom.
Well, no, it's not the
No,
weight of
not
one proton. It's actually what Joel said.
Yeah.
It's 1/12 of the weight of a single carbon 12 atom. That's what, so, you know, carbon 12 means you take a big handful of carbons, then you take out all the carbon 11, carbon 13s, and carbon 14s, and all you got left is carbon 12s now, and you get that mass and divide by the number of carbons, that's the mass of one carbon 12, then you divide that by 12. So this is 1/12 the mass of a carbon 12 atom. Okay, but you can always convert it to kilograms. If you look at your little sheets, do you see, look for the sheet where it says 1 atomic mass, 1 unified atomic mass unit, which they call 1U. Do you see how they convert it to kilograms? Okay? So you can always convert those atomic mass units to kilogram. But do you notice they've got another conversion as well? 931 mega electron volts over c squared. What do you suppose that conversion factor is telling you? Does anyone know 931 mega electron volts is equal to 1 atomic mass unit? What are they doing to this atomic mass unit if they're equating it to energy?
They're equating it.
What's that, Chris?
Nothing.
What are they doing? Is anyone thinking they are converting it into energy?
Oh, I was right.
Yeah, that's what that conversion is.
Yeah.
When they say 1 atomic mass unit is equal to 931 mega electron volts over c squared, what they're actually telling you is this. They're saying, hey, we're going to go E equals mc squared, right? And our mass is going to be 1 atomic mass unit times c squared. That's the energy. Well, if you multiply this by 931 mega electron volts over c squared, that gets you the energy of 1 atomic mass unit. The energy of 1 atomic mass unit is 931 mega electron volts. So when you do this problem, number 7 on 2001, I would like you, part A, to just express your answer in terms of atomic mass units. Don't convert to kilograms. And then part B, when they want the energy in joules released during a single fusion reaction, whatever your mass loss is, just multiply by 931 mega electron volts, and that's your energy loss. So go ahead and do part A and B now, using for part A, atomic mass units, and then part B, whatever your atomic mass units is, just multiply by 931 mega electron volts, which is millions. Please do that now.
Wait, what? Okay.